Hi guys, it's Mrs. Shakwa with Core 4. It's April Fool's Day. Ha ha ha. Anyway, but today we're going to cover inverses, Cramer's rule, and partial fractions. And I'm just going to show you how a calculator can do it. Oh yeah, I need to go into my calculator part. Hold on. Okay. So here's this picture for this week. At the moment when you find out the math question you solved by yourself is 100% correct. It's my picture for the day. All right, gotta go fast for those ones so you can't read them. Okay. Webinars are at 2 o'clock. All my contact information at the bottom of this PowerPoint or this webinar. I just wanted to show you this. I posted this in Schoology. What it is it shows you how to insert matrices into a graphing calculator. Because one component that I want you to kind of look at, today we're going to be talking about an inverse and hold on. And a graphing calculator can do an inverse of a matrix. And so anyway, you can also do a determinant, but I'm not going to show you how to do that one. So here's our rule. Let A be a coefficient matrix, so in other words, it's just a matrix of n linear equations and n variables given by A times x equals B, where x is a matrix of variables, B is a matrix of constants, A is invertible, then the system of equations has a unique solution given by x equals A inverse times B. Now what that's kind of saying is if I were to take this matrix here, so what that would look like is we would have A times x equals B. Now A would be 2, 1, -1. And then we'd have 3, 2, -4. And we'd have 1, 6, -3. Now just a reminder where these suckers come from. They're the coefficients from there. Coefficient of a magic 1. Okay, and then my x, 1 would simply be x, y, z. And then my equals would be -13, -31, and 12. Not 31, 36, I lied. Okay, so then if we plug those into a cool graphing calculator, and there's a lot of online graphing calculator versions, so I'm going to show you how it worked out. So this was my first matrix that I put in. This was my B. Then what I needed to do with my first matrix is I needed to do the inverse of it. So, and it was a function here. So my inverse was right here. That was my inverse, and when I punched in the inverse, it gave me this matrix here. And you just have to like go into a graphing calculator, do online matrix multiplication or graphing calculators. And then what I do is I take A inverse, so I'm going to use red now. So I take A inverse, which is this, right? And I want to times it by my B. So that's what happened here. Is this A actually is my A inverse. It's not A, it's A inverse. And when I times it by B, when I multiply those two together, oh, I didn't put the answer. That was dumb. That was funny. That was dumb. So anyway, what I have to do is I have to come up here, open up a pod, do a share my screen. I want to share my screen. I'm going to do Firefox, share, and let's come here. gonna just Google online matrix multiplication calculator. Math is fun. Matrix calculator. Okay, so I'm just going to do what I told you I did, and you can just watch me do it. 2, 1. Oh, let's make sure that it's big enough, though. Let's make sure I made my screen big. There we go. Okay. So now what I'm doing is just matrix multiplication. So you have to rewind a little bit to see what I did, but I went to a website and I Googled online. What did I Google? And then I need to make this a 3 by 1 because that's going to be the equals -13. Whoops. -13, -36, 12. Okay, and this one, like I talked to you, I want to click on inverse of A, and that gives me the inverse of A. Now what I want to do is I want to make that A's matrix. I'm going to set that to there, and you can see that the box here changed, and I'm hoping you can kind of see my moving around. So now I'm going to do A inverse, because this is no longer A, it's A inverse times B. So I'm going to do A inverse times B. There's my AB, there's my AB. And I get -6. So I'm going to put -6, 7, and 8. And then we'll come back to my screen. Hide. Okay, so -6, 7, and 8. And what that means is that x equals -6, y is 7, and z is 8. And those are my answers. Okay. Anyway, so if you came in late, there's no idea you knew what I was just talking about. But anyway, here's a determinant pattern. And once you get into determinants on a big scale, so tons, I want you to memorize this pattern. Super easy. Starts with a plus. And then every other cell switches. Should you switch the colors? Because usually negative's a red color because people are negatively impacted by. Okay, so just remember that little pattern. I wanted to point it out because I didn't see it pointed out in anything else I've read. And this is how you find the determinant. You probably would have already come across this rule for the last lesson. But what I want you to notice is A is in a positive position, B is in a negative position. I don't know. And C is in a positive position. And notice how this A is just A. Notice how there's a negative in front of this B. Notice how there's a plus in front of that C. So they take on, and that comes from this one here, the plus, the minus, because my A, it was A, B, C, so then it was a plus A minus B plus C in our position for the next one. Yeah, I don't know how long it's going to be. I always hope that these only last 15 minutes, but it's already been 9, and I've only gotten to one problem, and I think I'm doing 3 problems. Okay, so here's a shortcut, but it has to be on a 3 by 3 matrix for finding the determinant. Okay, but it has to be a 3 by 3 matrix. 4 by 4s don't work this way. So what it is I have my matrix here, and then I just rewrite the first 2 columns I just rewrite the first two columns side by side because what's going to happen, what this positive line is, let's see, we'll do that. What that positive line is A times B times C. A1, B2, C3. And you multiply them, and then you multiply B1, C2, A3, and you add them to A1. So this is a pattern that I'm going to take. I just wanted to show you. So if you need to go back and watch this and pause and take notes, then do, because these are kind of quick. And then here's Cramer's rule. Just remember, anytime I have the bars, that means find the determinant. And going back one slide, that's how I'm going to find the determinant. It's by doing that. Okay. And the other thing I want you to notice is see how this is X and I replace my X column. Okay, I need to delete what I just did. Delete everything. This is an X. I replace my X column with the equals column. This is my Y. I replace the Y column with my equals column. And the Z, I replace my Z column with the equals column. So those are just some of the patterns that I want you to note. So let's go and do Cramer's rule for this one. I got smart. I actually worked it out. I think. Yeah, I actually worked it out. So when I come up with all these crazy numbers, you'll know why. So what I'm going to do is I'm going to first work out one part and then I'm going to use this other board to figure out the other because, all right, not because anything. This is just kind of cool math. And you may just want to sit back, watch, ask questions when you're like, I have no idea what you just did. We'll call it the determinant of A. We're going to do 8, 3, 2, 12, negative 8, 3, negative 12. Uh-oh, I totally ran out of room already. Delete it all. Let's try again. And so it's 8. Now what I told you, a trick of the trade is to rewrite the first two columns. And then what I'm going to do is in green is what I leave as a positive. When I multiply that set there, I get 384. And then when I multiply 12 times 12 times 2, I get a positive 288. And then when I multiply negative 24 times 3 times 3, I get negative 216. Okay, now I'm going to do it from the other direction. I'm going to start with 2 times negative 8 times negative 24, and I'm going to minus those. So that's going to be minus 384. And it was minus a positive, so that's net effect is a minus, right? Then 3 times 12 times 8, and that's going to be minus 288. And then I have negative 6 times 3 times 12, so that's going to be minus a negative. And so we're going to add 216. Now when I combine all of these terms together, that equals 0. So what this means is there is no inverse. So I actually can't find the determinant. Cool. Let's work another problem where we can. So let's use Cramer's rule to figure this one out. So let's do determinant. This is going to be a 1, 6, 3, 1, negative 2, 4, 1, negative 1, 2. Now the trick of the trade is to rewrite this column 1, 6, 3, 1, negative 2, 4. Now, they show you how to do 3 by 3 determinants differently. So if you don't like the way I'm doing it, then pick another way. The other way is kind of cool too, and it kind of builds out to the rest of it. So this one is going to be negative 4, and then 1 times negative 1 times negative times 3 is negative 3, and then 1 times 6 times 4 is plus 24. And then we're going to go up. 3 times negative 2 times 1 is a minus a negative 6. So I'm just going to write the double. 4 times, it's going to be negative negative 4. And then 2 times 6 is going to be minus 12. And when I sum those all together, that's going to give me 15. Okay, and so then we have to figure out what x is, y is, and z is, and then we'll put it in the way that we usually see our answers. So we're going to go use the whiteboard to figure out x. It's not a whiteboard, but the uploaded PowerPoints write better than my whiteboard, so I think I might have found like a really cool, So z, well, we're not going to do z first, let's do x first. We're going to replace the x column with the equals column, so that's going to be 12, 16, 28. And then the rest is going to be what was in there, so that's a 1, negative 2. Can you see that? I don't think you can see that. See that? 4, and then 1, negative 1, 2. And then just to make my life easier, I'm going to go ahead and put the 12 again, 16, 28. And if I were you, I would use a calculator. 2 times negative 2 times negative, or positive 2 is negative 48. And then 1 times negative 1 times 28 is negative 28. And then 1 times 4 times 16 is positive 64. And then we're going to times the other one. 28 times negative 2 times 1 is minus a negative 56. And then 4 times negative 1 times 12 is minus a negative 48. And then 2 times 16 times 1 is negative minus 32. And when we add those all together, we get 60. But x equals determinant of a over the determinant of a. Determinant a according to x over the determinant of a, so that equals 60 over 15, which is 4. So x equals 4. Cool. Do anybody have any questions on that? So that's how we're going to have to find y as well. Ready? Oh, no questions. Okay, you're just enjoying the beauty of the math of it. So let's do y equals determinant of a and then of y over the determinant of just a. So we already know that's divided by 15. So then we're going to have to figure out what that top part is. So let's rewrite it. We have 1, 6, 3, and then we have to switch the y column out for the equals. So that's 12, 16, 28, and then we got the z column 1, negative 1, 2. And then to be friendly to yourself, you're going to just rewrite the first two columns. Okay, and then we're just going to work it out. Multiply those, and you get 32. Multiply those, and you get negative 36. Multiply those, and you get 168. And then you're going to multiply minus 48 plus 28, and then minus 144. And when we total those together, we get 0. Divided by 15 is 0. And then let's go to Z. So we're just going to rewrite, this is going to be all over 15. 1, 6, 3, 1, negative 2, 4, and the equals guys, 12, 16, 28. Be nice to yourself, add the 2 columns. We're just going to multiply. We're going to subtract. When we total that all together, we get 120 divided by 15, and we get, I don't know, 8. So then Z is 8. So in other words, if X equals 4, Y equals 0, and Z equals 8, then we have our solution to our systems. Okay, and the other thing I wanted to just talk about real quick, because I don't think I ever have, and I don't know if it's ever come across that way or not, is when we're talking about systems of linear equations and the type that we have. Okay, we need to delete that. That's your y-axis. That's your x-axis. And that would be your z-axis. Kind of making stuff 3D. So we're working in 3D models, which is really awesome, by the way. Just awesome. Okay, so when you watch this again, pause it and take notes. This is also in Schoology when you look at this section for the partial fractions. It's in there. You may want to take notes on partial fractions because it's just kind of cool anyway. But so I'm going to follow these steps. So what you do when you're dealing with partial fractions is we're going to decompose it. First thing that we're going to do is multiply each side, distribute a property, and group your like terms. Okay, so we're going to go work a problem. I'm going to show you how to work it. It's a little bit weird. First, you want to do long division. Ready, set? I'm going to take x squared plus 2x and divide it into 3x squared plus 12x. Probably going to like kind of go down memory lane with this a little bit. With long division otherwise. How many times does x squared go into 3x squared? It goes into it 3 times. And so, okay, I'll see you later, Ashley. We're going to get 3x squared when we multiply it plus 6x. And then we have to go through and we have to subtract this row. So I'm left with 6x plus 4. So as we break down this fraction, and x squared can't go in there, so then we simply put it over x squared plus 2x. And this is the one that we have to decompose. Okay, so my answer is 3 plus, and then we're going to go to the other whiteboard and work out that 6x plus 4. Scooch. So I got 6x plus 4 over x squared plus 2x. That didn't work out very well. And what I want you to realize, this is x and times x plus 2. Got to pull in our factor skills. So this is going to equal a over one of those factor parts plus b over the other one, x plus 2. Okay, now the next step was to multiply everything by this LCD. And when I do that, these LCD schnicks, I'm left with 6x plus 4 equals a, the x for my LCD, which is x plus 2. That x will cancel, so this leaves me with a times x plus 2. And then this LCD was x plus 2. Well, the x plus 2 part will schnick, so this will be just plus b times x. I'm going to distribute, so I got ax plus 2a equals bx, not equals anything, plus bx equals 6x plus 4. Okay, this is an x term, this is an x term, and this is an x term. So I'm going to set ax plus bx equals 6x, which then becomes a plus b equals 6. Now watch carefully because this one actually turns out pretty nice. I use white because I can. This 4 doesn't have a variable, right? So then 4 equals 2a, a equals 2, which therefore b equals 4. Kind of cool, huh? So then we're going to come back up here to this bluish stuff, and we're going to rewrite it in our thing. So it's going to be plus a was 2 over x, plus b was 4 over x plus 2. We'll rewrite that 3. So that is my partial fraction decomposition. That's it. That was kind of hard, but it's kind of cool still. Okay, next week, a reminder, I have section 5. We'll finish up the unit, and we'll have a test and a pretest. And then that's it. Okay, do you have any questions? What does that mean? So, no, what we covered today is for this week's material. Well, I don't even know if I understood your question. I'm just going to talk, and then I'll see if I answered a question that you might have asked. What I covered today was for this week, and then next week we have one final section to cover, but we also have the test and the pretest. Did I even next week being April 4, 5, 7 to 11. Yeah. The test, remember, and that's a really critical point, you don't pass the test, you don't pass my class. No test, no grade. So yes, the tests are important. And so make sure that you get her done. There's going to be 2 tests and a quiz. Like a test. It's going to be 2 tests and a small test. Because I want you to learn, we're going to talk about polar coordinates, and I want you, it'll be a super short test. Because we've got 8 weeks in this quarter, and 3 weeks for one test, 3 weeks for another test, and then it's going to be 2 weeks of material with a test. Yeah, yeah, and the small test will probably be, I don't know, like 5 questions. And that, yeah.